Alright, here's the OMAX tutorial. So basically what we're going to start with is go into Onshape, and we need the 2D profile. So to grab that we can do a right click and export as DXF. So I've already exported it, it'll just download to your computer. Then what we need to do is find Protomax, the layout software. You can download this from their very sketchy website. Let me know if you have trouble finding it, but you can do that, or you can just go into the CLC and grab it from there. So go ahead and open this up. So you just import your DXF file from uh, Onshape directly, and this is what we have. So I have an on-screen keyboard, so you can kind of see what my keystrokes are as we move along, because the keystrokes are definitely necessary for this terrible program. So first we're going to select all, and then we're going to move it. So that'll be select all as SA, and then the move is just M. You can scoot it over till it's kind of in the actual grid a little bit, and all of your movement is done with a scroll wheel. It's odd to get used to, but not too terrible. So then we'll go ahead and deselect it and bring up the quality menu. I think 3 is really the only thing that we're going to use. It's fine. It's good enough for pretty much everything that we do. If there's one feature that is just like, okay, this needs to have a little bit better of a cut quality, then we can do deviate outside of that. But 3 is general machining, and it's pretty fine. So go ahead and select all with our quality, and it's not wanting to select them. Okay, there we go. So then now that, as you can see, everything is purple now. That means we've selected the quality and it is purple. You basically do that by going to the menu, select all, go into the menu, select all again, and then that's insane. Okay, so we need to select all of our part, and then go into the menu, click the button, and then select all again, click on it again, and then it will update apparently. That's odd. So then you'll see there's an AutoPath tool. You can click on it and it'll do a bunch of stuff, and I'll kind of show you what it looks like. So this is the AutoPathing tool, what it created, and if we try and post this, and alright, select zoom tools, select all first, and then post. Then, oh right, I forgot. So we have to pick the starting point. That's what this leading line is. Pick the start point, and then it'll basically show you how it's going to cut everything out. You can use check for problems. It's extremely helpful. So to give you a little bit more insight on what this actually means, the oh that's really annoying. The collisions is where it's going to cut something out and then move over the area where it cut it out, and that can cause basically that little part that you cut out to kind of lift up and get in the way of the nozzle. That's what the collision is. You want to avoid that as much as possible. So just like using lines to move, and I'll kind of show you how you do that. And then we also have offsets to wrong side. So depending on how you put the lead in and lead out leaders, it will cut it inside or outside of the path. As you can see, what we want is the kerf, which is this red section here, to be on the inside, because it's an interior feature, but it is the opposite of that. So what needs to happen is the in and out need to be switched here. So we'll have to kind of do that. So I think basically what I recommend is just not worrying about the auto path feature, because it sucks and it doesn't really work very well. So I would probably just go ahead and like do it from scratch. It's definitely more work, but you'll get something that's not terrible. So you'll basically just add your lead-ins and lead-outs for all of the different features, and you can do that by just kind of going along and adding them all in. Alright, so the key command for that is V, so you can just click V and add them. Just going along, adding all of the lead-in and lead-outs for each of the different features. Obviously, it'll get a little bit tedious if you have a lot of them, but it goes pretty quick when it's fairly repetitive, so it's not too bad. So, and basically you want to do that for every loop that you have. That's what we're trying to do, is cut out each of the loops. So then what we can do is we need a starting line. Make sure that you don't start by cutting out the outside perimeter, because that means that then everything else is just floating. So you have to make sure to cut that at the very last step. So if I remember right, I think it was backwards for lead in, lead out. E is the snap tool that'll snap to a point, and then L is the line tool. So L, E, snap to a point, bring it over, snap, and then basically just repeat that process along each of the different lines, and make sure to try and not I guess this is not a very good example, but try and not run over the piece that you just cut. So basically this will come in, it'll cut all around, and then it'll go out. This will come in, it'll cut all the way around, and then it'll come out, and it'll walk over the same part that it's already on. So honestly, with these lead in and lead outs, what I should do is have them poking out the bottom here, and then I'm not traversing over the material that I already cut. And if you have trouble, you can just kind of talk to me, or the water jet guides are very helpful. So we'll go ahead and make that change. I'm trying to remember which way it is, but we can find out in 1 second here if we just go to that posting tool that we just saw. So if we do it this way, it's a little bit of a better representation of what working in this program is like. Oh, I missed completely. Let's add the snap, move over. Alright, so now that I have something, I'm going to go ahead and click the post tool. I keep forgetting. Start here. And as you can see, it'll go up to this. Okay, so that's going to be an issue. So it is the correct direction, but our lead in, lead out is cutting into the material that we want to keep. So that's not going to work. We got to have them on the inside. So what we can do is back up and add them back how I kind of had it originally. Just go to there, and then have our lines come in. E to snap will come in, and then go out onto the next piece. And then we can see if we post this. Alright, now it's the wrong way, because since we swapped the side that we were leading in and leading out on, that changes the direction. So you have to be very careful with how you're doing these, because they will definitely give you issues like these a lot. And it'll say, okay, hey, we have, this is on the wrong side. So that's a nice tool to have. So since it swapped them, we go in. Now you want to snap to the bigger side, you can snap from snap onto that end, pull it over, and post. Pick the starting location. Now we can see, okay, we're coming from over here to over here. We're starting, we're cutting around, then we're going out. And I think the only problem, no, it's fine with that. So that's what we want because we're cutting only material on the interior of this feature because this feature is an interior feature. So that's what we want to cut. And we wouldn't want to cut it the other way because that would cut extra material. All the kerf would be on the inside of the part that we want to keep. So we kind of have to pay attention to which side that we're cutting on. And then basically you just want to repeat that for, you know, all the other features. So I'll go ahead and pause here for a second and just put some more stuff in so you don't have to watch the entire thing. Alright, so that's basically kind of the path that I took there. Just making sure to not go over a second time after I cut the shape out. So you can see right there, I kind of had to do a lead over here before going because otherwise straight through this point would just go through this section where we don't really know the condition. Like this piece could kind of tilt up and get in the way. We don't really know, so we're trying to stay away from it. So if we go ahead and post this, pick our starting location, see how this does, then we can see that, okay, still not super happy with the collisions, but we have everything on the right side. So that's looking good, and it's upset about the collisions, so we might have to move our spots around because it's kind of not happy that these are occupying the same location. So this will go around and then go over that spot again. So let me go fix that real quick. Alright, so I'm basically just going to redo some of this, and I'm going to do a little bit with you guys. You can kind of see the process of what I'm doing in here. So I'm just kind of adding leaders, and then that was a little bit small, so it's hard to see the in and out. And then what I'm doing is, honestly, that's a bad placement because it's going to cross over itself. There we go. So now we have a clear path from this one to this one. So then I can do the snap, snap, and then throw another leader in. And let's see, we'll want it up here. And then snap, snap, put it over there. And then I'll kind of keep doing that and just be a little bit more cautious about the direction because basically what we're avoiding is having the path collapse over itself. So the collisions is happening right where those leader lines are just kind of intersecting each other. So just got to be a little bit more careful about putting the lines on. And then basically if we take this, kind of see what's going on. So then now it's not happy because we are here. Give me 1 second. Alright, so basically what I just did is went through and every time that it was colliding over a part, you basically, every time it tells you you're colliding, you basically just need to make the path, the lead out path, not go through the edge of the part. You need it to kind of go close to the lead out point. So it only really crosses over right there. And that will make sure that the tool head does not collide with the actual workpiece. So you can kind of just see how I haphazardly darted around the sides of all of the features to make sure that the toolpath isn't going to collide. There's other ways to do it. You can use a heads up traverse and basically just have that instead of a regular traverse, you would do a. Let me see if I can select this. Instead of doing a regular traverse, you can do the heads up traverse, which, oh, I guess that's not going to change it. I don't even know how to get to that. Oh no, that's normal traverse. So there's a way that you can set it to do the heads up traverse, but honestly, it's not really worth it. You can kind of just go around the part. um, it also helps out for machine time a little bit when it doesn't have to raise and lower the z-axis because it's kind of slow. So, oh, I'm going to, before we move on, I'm going to go ahead and select this, remove it, pull the line down closer to here. So then when we post it, then go ahead and pick that as my starting location. And we can see that all of our parts have the kerf of the water jet being on the inside of the part, our lead in and lead out are on the inside of the part, and we don't have any collisions or wrong offsets. Um, Now that we did the outside, it kind of knows where the offset is. Before that, it kind of just has to take a guess at which side is the wrong offset. So when it gives you this error, it's almost certainly meaningless until you have the entire part done. And even sometimes still, it could be meaningless. It's basically up to you to be like, okay, this is, where I want it to actually cut. So that's important to keep in mind. Keep in mind the traversing options. Make sure you lead in, lead out of the part in a way that makes sense and a way that you can get around the cutout section. That way the head doesn't smash into an already cut part because basically it'll cut this out, and then if you leave it traversing through that, it can hit that edge of the part. So other than that, there is a couple other things I'm going to say about the actual submission of the files, but that's pretty much it with the actual OMAX part of it. If you need help, let me know. I can definitely answer some more questions and try and help out with that kind of stuff. Uh, but I think that's a pretty decent overview. As far as the actual file submission goes, um, it's pretty simple. It says it everywhere in the SDelc. When you save, I guess I'll show that in a second here. Make sure to save it as an ORD. It doesn't get any extra information. It's basically similar to G code, but for the water jet. The machine has some proprietary file types, but what you're going to do is put your team name, your username, which is your MST username, so whatever that is, part of your email, whatever the username part is, and then the name of the part and thickness and what the actual material is. So you'll have to do this for every single type of material and thickness of material because they'll put the plate on and then run the file. So you can't have all of your water. You need to make sure that you're submitting one file per type of material and thickness of material. Um, you have to leave 2 weeks notice. So when you're putting a instruction, make sure to put that. And then, so once after you fill out the information and submit the request, make sure to actually drop off the material. So we have all of our material back by the water jet area. You should have seen it on your original tour, but if you don't remember where it is, let me know. And there is the drop off there, so we'll have to take the stuff out of our bay and go ahead and put it in the drop off for the water jet. So that's pretty much it with the file submission. As where to submit it to, you're going to um, go ahead and email Steve the ORD file with the team name, the time it's needed by, the number of runs, which for all of the stuff that we're doing right now will just be one, and any other instructions that we have, which we really shouldn't. And this is the email right here. So make sure to send that to Steve and go ahead and copy me so I kind of get an idea of what's being submitted. And if you do have any questions, let me know. I'd be more than happy to help out. Thanks, guys.